Okay, hello everyone to the Stateless Implementers Call number 36. I will share the link to the agenda in the chat. So as a brief overview, we'll have the usual team updates. Then Karim will present the Hood State reconversion presentation. And then Guillaume will talk about the EIP 4762 revamp. So yeah, let's start with team updates. I can start. I've been working this last weeks mainly on the CGVM benchmark suite stuff. Probably in the next week or the other, I will do some presentation to explain a bit more what this is all about. But yeah, that's kind of my main update.
I'll go next, I guess. I have been still working on getting some stuff merged into Geth, like Geth Master. That has actually happened. There was one PR merged last week. So I'd say another 8 to go. And otherwise, I was working on the rebase of the Kelstinen with Chapella branch, that whoever has worked on the previous testnet knows very well. So there's a new branch called the Kelstinen with Spectra. It's not passing all the tests yet, but I think we're slowly getting towards the ability to launch a new testnet. Yeah, so probably over the summer there are some changes to consider, but yeah, overall I think it's starting to look good. And right, over the summer in the northern hemisphere. And then I was working on the EIP 4762 update, which some of you might have heard of, and I will present it afterwards anyway. It's also supposed to include 7702, but yeah, like there's still some work needed. So yeah, any input is welcome. And I was also working on the implementation, the binary tree implementation. And the binary tree implementation has some differences with the spec, which I'm trying to resolve today. So hopefully I can field the tests and share them. Okay, maybe not today, but tomorrow. And the last thing is we were started on I resumed the work on Fent, the stateless client. And yes, it's more or less able to compile with the latest version of the compiler. The only issue is compiling to RIS5, RIS532, which I'm currently working on. And that's it.
All right. I can go with Ethereum JavaScript. So we've done a work on a few fronts. The main one is working on the conversion testing with the test vectors that Ignacio has coded. So I've asked some questions in Matrix. Our implementation is in a much better place now than it was. We have added the conversion logic to the VM, and we have an overlay state manager that handles like the dual three fine. So we are able to do all the fallback logic and the conversion logic. There is still some bugs related to the pre-image saving. Some of them might be just related to how we are using it in the actual test vectors, since it's a bit different than what we would do in actual production. But yeah, some pending questions. And we've also helped out with EIP 4762, I think the one that you were talking about, Guillaume. In general, I'm very much a fan of simplifying that EIP. I think it's in a much better place now, especially with the comments from different people. So yeah, that's it for us.
Yeah. So on Bezos side, still working on transition. So I will show you some result I had, and this transition test was really nice because it helped me to find some issues in the Besu code. So I'm continue to investigating and trying to fix the issue I can detect. I also shared with Thomas the last update. So Thomas, I think it would be nice if we can switch to the binary tree implementation. So I think we will start maybe this week or the next week to start implementing binary tree in Besu. And yeah, I think it's all on the Besu side. Yeah. Yeah, Thomas?
Yeah, thanks for the update. Yeah, no, so we were working on stateless execution, but yeah, so we'll do the binary tree first. It's a much better idea.
Also, Luis, I think you worked on an RPC modification in the tracing. I don't know if you want to share your modification, Luis.
Yes, the PR actually went in today. So I added a debugging for this the witness, the access witness, into the traces. So each opcode now prints out the access witness at that current state, that current opcode, and I'm still missing and maybe adding access witness hash, which was requested in Matrix. But yeah, I will be sharing. I had to make some adjustments to the format. I will be sharing the new format in Matrix. That's all.
Yeah, I think I can go next. Nethermind. So after the rebase, we are now passing all the hype tests on the Pectra branch. And I'm very close to merging the transition in the Pectra rebase as well. So I'll run hype tests and transition and update like how going. Then after that, I'll maybe also start testing the transition with what Kerim did and try to transition the Hoodie state. And apart from that, I'm also thinking about starting working on the binary tree implementation.
I'll go next then. So from my side, I've been mainly working on including all of the scenarios in Spamor for BlockNet, and also had a call with the Nethermind team last week in order to start coordinating how to set up the whole testnet and how to start bloating it, basically. The research, at least from my side, is completed on state bloat attacks and the easiest ratio to increase the speed of filling the whole testnet. But welcome any ideas on how to attack nodes when state is massive, or how to make the state bigger at a faster pace. Aside from that, I've mainly been working a bit on some survey that we're preparing for wallets and dApps, at least the major dApps and major wallets, which is kind of related to strong statelessness. So basically similar to the post that you might have seen from Vitalik to date. I will link it down here, where the idea is to basically allow wallets and dApps to basically supply some auxiliary witness, which basically results in a discount for all the reads that the node doesn't need to execute. So basically we're saving X amount of IO, and the outcome is X amount of gas that you basically don't pay for, maybe some other kind of reward on the top of that. That could heavily alleviate the amount of data that you need to access as a full node, especially when the state becomes much bigger. And the counterparty is wallets have a really nice feature to give to the users, which basically provides them savings and where they are able to take a fee if they want. So the idea is to see how wallets would see that, what do they have in mind, if they have any other plans, if that is good or bad UX, how we can make it better, and try to see if there's some kind of weak transition that we can do towards a bit more stateless related regime, let's say. So that's it from my side.
Anyone else want to give an update? Okay, so let's now move to Karim's presentation. So whenever you are ready, Karim.
Yeah, I try to share my screen. I don't have permission, so I can maybe give you a link. I don't know if you have permission, Ignacio.
I should, but I'm trying to see how this works to give you permission.
Okay.
Let's see. Not really sure how this works in Google Meet. Does anyone know?
I can send you a link, or you can maybe try to share directly.
Yeah,
Could you
send the link and I can present it. Yeah.
Yeah, could you try?
Yeah, give me a second. Okay, let's see. Can you see my screen?
Yes. So it's not a long presentation. Just wanted to explain what I tried to do during the several weeks, the last weeks. So what I started to set up is so it's a CL using Nimbus connected to Hoodie, and I'm using two kind of Bezu nodes. So I have a vanilla Bezu node. It's a Bezu node using a Patricia Merkle tree. And this one is just following Hoodie, following the head, and generating a pre-image. So Gary from the Bezu team added a feature into Bezu like that we can just generate pre-image and save it in the database. Like that, I don't have to generate every time a new pre-image. I will just have to ask directly this node in order to have a pre-image of an address of a slot. In order to do that, I added a specific RPC endpoint to this node. Like that, I can just ask a key of or a slot, and I will retrieve the pre-image. So it's not really good regarding performance to do that for each key, asking RPC node using RPC request, but it's not really a problem because even if I was doing that, the block time was 1 or 2 seconds, and it's not a problem because slot time is 12 seconds. So I didn't want it to try to have a really performant block import time, just wanted to check the transition. And I also have a second Bezu node, so it's a Bezu node using Verkel. So I'm starting a Bezu node with the Bonsai, Patricia Merkle tree. And after a specific Verkel timestamp, this Bezu node is switching to Verkel and starting the migration and asking this vanilla Bezu node in order to have pre-image. So you can go to the next slide. So just to explain quickly what we are doing in Bezu in order to manage the two states. So we don't really have an overlay tree. What we have is more two states working together. So we have a world state Verkel and a Bonsai world state using Patricia Merkle tree. And we have a facade, and this facade will manage the two kind of world states. So depending where we are, if we are before the Verkel fork, it will just redirect to Bonsai. If it is during the migration, it will redirect to Verkel with a fallback to Bonsai. And if it's after the migration, it will just redirect to Verkel. And this facade will also manage the different reorg of the different states regarding what we need. So yeah, just wanted to explain that. So you can go to the next slide. So in order to do the migration. So what I did is to not modify the genesis because I didn't want it to have a fork, invalid fork ID. So it's not really a shadow fork. It's more a Besu node following the Houdini network and trying to generate each block of the Houdini network with the Verkel state. So like that, for the moment, I cannot really validate the state root, but I cannot validate the execution of the same block and compare the gas used for each block. For the moment, the Verkel milestone, the Verkel timestamp, it's hard-coded directly in the code, but I want to have a specific flag like that. I don't have to rebuild every time to restart a new test. But for the moment, in order to be able to be connected to the other peers in the Houdini network, I didn't add it directly the Verkel timestamp in the genesis. So if you go to the next slide. For my test, so I started to have 5,000 leaf to migrate from the Patricia Merkel tree to the Verkel tree by block. And when I was using this configuration, I saw that even if we are just migrating 5,000 leaf by block, in reality, we are inserting in the Verkel tree more than this number. It was between 5,000 to 9,000 leaves. So it's logic because when we are creating by one per account, in reality, we have to insert two kind of leaf. We have to insert the basic data and the code hash. So we need also to have in mind that when we are choosing a number, in reality, we are inserting more than that in the Verkel tree. And if you go to the next slide. So on my test, the migration, it was 13 hours for Hoodie with a slot time of 12 seconds. And I also saw a state root performance issue on Besu. I don't know if it's only on Besu, but it was 1 second to generate the state root with 8,000 leaf in general, something like that. We have all of the optimization normally in Besu, the way to not calculate all of the commitment every time, etc. But I didn't really want it to look at this part because we are talking about changing the crypto, and so I didn't really want it to look at this part and trying too much to optimize the state root computation. So if you go to the next slide. So as I said, how I'm validating the migration. So for the moment, it's not perfect because I cannot really validate the state root. But this kind of test helped me to find some reorg issue and also a rollback, roll forward issue, because in Besu, we are just saving the head and we are using trilog to roll back the state or roll forward the state. And thanks to this state, I was able to find issue in my trilog because in Hoodie we have sometimes some reorg, etc. So it was nice to do this kind of test for that. And I'm also validating the migration using the Ignacio reference test. And what I said before, I'm using mainly for the moment the gas used for each block to be sure we are executing this block in the same way. So for that, I just disabled the Verkel configuration for the gas, and I'm using the Prague configuration. And I'm also checking if we don't have invalid nonce or something like that. So this is the main test I was able to do for the moment. If you go to the next slide, I think I have still one. Yeah. So what I want to do for the next step is I need to test with a network with more transaction because I want maybe to find more edge cases. Guillaume said maybe he will be able to give me a pre-image for mainnet. For the moment, I was using Besu. I was using Hoodie because it's really simple to sync a node with the Hoodie network and generate a pre-image. But for mainnet, it's more complex. So if Guillaume can give me maybe a pre-image for mainnet, I will be able to do the same test. And also, if we have more clients that can do the same thing, like that, we'll be able to compare the state root. So it will be also nice. I think it will be the best test we can do. And yeah, it's all on my side.
Yes, Guillaume.
Yeah, I'm thinking another way. So yes, if we have more clients, it's true. It's hard. Like as long as you're alone, it's really hard to test the state roots. There's still a very useful and important test. It's the ability to produce blocks and reinsert them back. But of course, if you're just following the test net, it's hard for you to produce blocks. This being said, if we have more clients, you can also check what the witness or at least the state diffs look like, because right now, but we would not be providing this, right? So you could only verify this after the end of the transition. Yeah. Okay. I had a couple questions. One of them is actually it's not a question, it's a remark. So when you say you don't have an overlay tree, but you have a facade, it's the same thing, right? The overlay tree is effectively the facade, what's that called? Pattern, object pattern. I forgot what is the object-oriented term for this, but it's a pattern, design pattern. That's it.
Okay, so you have something similar. Okay. Yeah.
No, I mean, yes, we do, but I call it a transition tree in the code, but it is exactly that, right? It's just a tree that does the redirection. So that's, I mean, as far as I know, that's the way to do it, and that's how it's been designed to begin with.
I'm not sure it's exactly the same, but yeah, okay, we can discuss about that later.
Yeah, sure. There was another question regarding the size. Do you know how much size is the state of Hoodie? I should have checked that, but I don't know it from the top of my mind.
I didn't check. I started a new migration. I can maybe give you the number after the. Do you mean after the migration or before the migration, or maybe comparing the two sides?
Before the migration and also after, actually, yes.
Yeah, I can give you that when the migration will be finished. I will take the size of the state, and after I will go back to the state before migration, and I will send you the two values. Yeah.
Yeah. Yeah. Cool. And there was something else. Yeah, it's about the speed. So you took 5,000 leaves, and you said like the worst case you got, or was it the worst case, like 1 second, or was it more like an average case?
Oh no, I think it was more average because, as I said, it's not a good number because for each key, I'm asking a second Bezo node through RPC request, so it's impacting the block time. But for me, it was not a problem because it was every time it was smaller than 12 seconds, so it's not really impacting the time of the migration at the end. But yeah, it was, this number is not really interesting. What was the number that was interesting was the stateful computation time. It was sometimes 1 second, sometimes more, and also the block time. Sometimes it was 1 second, sometimes 2 seconds or 3 seconds. So it's the block time for the moment is not important as I'm asking a second Bezo node through RPC request.
Okay, understood. Yeah, that's true. It's not very. I mean, that explains why it's not super efficient. Yeah.
So for the moment, as we don't really have a way to, we don't for the moment have a way to get a pre-image or to save a. We don't have the process how we will retrieve the pre-image. So I'm preferring to have this kind of mechanism. Like that, I just have to restart Verkel for a new test, the Verkel node, and I don't have to manage the pre-image every time. So it's more easy like that. But
okay. Do you select? So you said you were hard coding the Verkel time in your code base.
Yeah.
But what, like, I'm trying to understand, like, what prevented you from creating? Oh yeah, because you wanted to keep the chain ID and be able to follow the chain. Yeah, I see.
Yeah, I wanted to be connected to the other peer.
But could you not simply deactivate the fork inside the fork ID computation thing?
Yeah, it's just the way I decided to do, but yeah, it's also possible. Just I think it's more simple like that, but yeah.
No, okay.
on my side.
I'm not saying it's better or worse. I'm just trying to think if we want to build a version of Get that does the same thing. How would I do this? But yeah.
On my side, I was thinking maybe just to add a flag where I can specify this hard-coded value, like that I don't have to rebuild every time. But also modifying maybe Genesis and ignoring this specific fork could be also a solution. Yeah.
The last question I can think of is: did you write any data that you know, for example, like the state diffs or the things, or the state root or whatever? Oh yeah, no, you don't have the state root, but
I have the state root, just I cannot validate that. But I can give you some state root if you want. But
true. Yeah, no. The question would be, what happens if instead of building the entire guest thing, I would just import the blocks that as they are, and as soon as we detect the guest fork happens, basically getting rid of the whole peer thing. You see what I mean? Like just it's not as impressive because it's not technically a shadow fork, but as a way to test, it's much faster because you don't have to look for a peer and do all those things.
I think it was also interesting to manage a real scenario with connecting with peer, importing blocks, switching to the migration part and finishing the migration. It helped me to find a lot of issue in my logic. So I was able to pass all of the migration tests from Ignacio, but all of the logic to manage reorg during the migration, to finish the migration and go back to a Verkel mode without fallback. So it was also interesting to do this test because of that. The main part of my test was related to the logic on this part and not really related to the migration. Migration was working correctly. It was the other part.
Yeah, fair enough. That's true. So the reorgs is something that's missing because for me, because I haven't managed to get stuff into Geth, but I guess I could try to fix it.
I think migration is really it will be really tricky because so I'm trying to manage that, but it's difficult to exactly have this scenario. But I'm thinking about a scenario where you are starting the migration, you don't have the finalization yet, and you have to roll back Verkel, but also the Patricia Merkel tree, and go back to a new migration. I think we need to test this kind of reorg during the migration before the first finalization. I think it would be nice to have a test for that because
absolutely. Yes.
So we talked before with the testing team, because today in the testing framework you cannot really create these reorg scenarios, but they were planning to include this kind of feature soon. But yeah, as soon as we can create these kind of scenarios, we should definitely create kind of execution spec tests for all these reorg cases.
Yeah, because some of my test was also related to reorg issue. As I said, in Bezu we are generating this kind of trilog. So this is a prior value and updated value. It's similar to a witness, but it's internal to Bezu, and we are using this trilog to roll back and roll forward the state. And I will say the majority of this issue was related to how I'm generating the trilog. So having this test would be really useful for me. Yeah.
Cool.
But yeah, if we can just compare the state root like that, so if I can give you maybe some state root and you can verify it, it will be also nice.
Yeah, that would be a good idea. I mean, I still need to complete my rebase for it to work, but yeah, we should strive to do this. Yeah. Cool. No more questions for me.
Just to understand this latest idea, so the idea will be to maybe do some exporting of Hoodie or any other chain, decide on some timestamp where this migration will start happening, and multiple clients can simply import this chain and just compare state roots, right?
Yeah, I think it would be nice.
Yeah.
Nice. Cool. Anyone else has any questions for Karim? Okay. Yeah, great work, Karim. This is very helpful to really get deeper insights into how all this would work in reality. Let's move to the next item, which is EIP 4762 revamp. So maybe Guillaume, whenever you're ready.
Yeah, I'm gonna try to share. And also, while I do this, I also didn't say it, but that's really good work, Karen. Thank you for taking the time. Nope, as always, looking for Windows. Oh, is it the one? This is the one. Yes, excellent. So I don't know if you guys can see it.
Yes.
So yeah, there's this ER that's against Ethereum EIPs. It's meant to be a rewrite of 4762 because 4762 is very, very hard to understand. And it's been an idea that was floated around a previous stateless implementers call maybe 6 months ago. But I finally tried to do it. It's a bit of it's more than a bit. It's extremely difficult to do because the wording is confusing, but whoever worked on the topic knows that. And so the idea was to try to use some Python-like implementation to try to make it more palatable and more easier to understand. So as you can see, for example, in this example, if you can read it, you have like just a list of bullet points on one hand, and this is rewritten to be more like code. So actually the equivalent of this is more like here, yes. And the idea, so I had a talk with Guru from the EELS team, and initially I really wanted to stick to the structure of EELS. The problem with EELS is that it's not written to be like this. The idea is that they have this approach which is better for maintenance, I guess, but also really hard for specs, that when you want to implement a new fork, you just copy everything and you modify in place. And that would have mean, among other issues, that I would have had to do that work, and then just give a link to those changes. So the approach I tried to achieve instead is just say, like, this is what this function does, and I give an explanation before where in the code it goes. So yeah, like the first request I would have for everybody involved would be to have a look and tell me if, in your opinion, this is actually helpful, this is understandable. I am not happy with it, but I think okay, that at least that's the best approach I could find so far. While I'm at it, let me note that there is a mention about atomicity. So this was a topic last SIC, or the last few SICs, where we specify when the gas gets charged. So I describe it as this function that gets called is called charge gas, and whenever you have an atomic operation, which should happen at the end of this function here, that says, like, in between two calls of charge gas, all the events accumulated will be charged for. There are a few issues on this rewrite. Well, some of them are actually inherited from the previous version of this EIP. Some of them are something I found while working on this. That was a very good thing that I did this, because I could identify parts of the spec where the spec were actually not matched by code. So yeah, one of the things that is missing, it's currently not charging the warm costs. So I have to figure out the best way to do this. There's this question that actually, if Louis is here, I would like to discuss again because I'm a bit fuzzy on the details. The one with the call code, and the last issue, before we maybe delve into the call code, is I'm looking for it right now. It's that the spec, or at least the previous version of the spec, used to say that you don't charge any access for anything beyond the code length, and this is not true of what Geth does, for example, and presumably any other client implementation does, in the sense that if for whatever reason the code execution, or there's a jump, although that's not possible, but if there's a jump that happens after the end of the code, but still in the same chunk that the end of the code is present in, this chunk will be added to the witness. At least that's my understanding. I don't know if we have a test for this. I forgot to check with Ignacio first. But this is an issue that I think we have in the current implementation of Geth, at least. And this is something that especially Tanishq, Karim, and Gabriel, if you could check your implementations to see what you do in that case, because we might have a consensus bug, or at least we don't. Either we have a consensus bug because you guys do it right and Geth does not, or we're just not following the spec, and I think we should then fix it in the next version of the testnet. I see Luis. Oh, sorry, Gabriel, you were going to say something. Did I saw a flicker?
Yeah, I was just going to ask, what specifically is the consensus issue? If I'm just gonna note it so that we can review it internally.
Yeah. So if it's not clear, you can of course write me afterwards. But it's just that if you're executing a contract, like for example, think you're having a just a bunch of pushes, and then after the last push, your code ends. But the last push is, let's say, halfway in the middle of the chunk. What will happen is that it will try to execute the first instruction after the end of the code, which is non-existent, but it's filled with zeros. So that will be interpreted as a stop, and what's that called? The witness will consider, or at least the access management module will consider there was an access. This is the way it's implemented in Geth. Or if you do, for example, a code copy of the code just after, like still in the same chunk, but just after the end of the code, this will create an entry in the witness when it should not. Okay, according to the spec, it should not. So yeah, that's roughly what I would like you guys to check. If there is if you have such an issue, if you did it properly, or if you did at least according to the way it's specified, then we have a consensus bug because Geth does not do it right. Yeah, that's I don't know if it was clear, but that's the general idea.
Yep, that's helpful. Thanks.
Cool. I see Luis coming in and out, so I don't know. Maybe he's got some connection issues. Are you here, Luis? No mic. Okay. Well, it's going to be hard to have a conversation. In that case, I guess we can take it offline. But as a summary, I noticed that the spec was saying call code should behave exactly like call, and Geth does not handle this. I'm pretty sure we discussed this in the past, but I'm a bit fuzzy on the details. So I would need to figure out. Yeah, like you said, we should. On the review, you wrote we should fix call code on this side, which basically what we want to do. Yes, it's a self-transfer. I think so as well. Right, that was it. Yeah, it's a self-transfer. So but yeah, it's not properly specified, or at least it's not properly coded in Gas. Or if it's properly done, it's really not obvious when you read the code. So I think, I mean, I will spend some time clarifying this, and I will need your help if you're so inclined as to help me. Okay, yeah, I guess we don't need to talk more about this. And yeah, the last thing I already skimmed over, but want to remind, if you guys have an idea on how to properly represent worm costs, because what I did was not good, or at least it's just not correct. And I'm still thinking, how can I best do this? I'm just thinking, yeah, I think that's pretty much it. Just thank you to Gabriel and Louis for reviewing it. Actually, it's been quite useful. It caught a lot of issues, but yeah, there's still a lot more. So this is the first draft. I will make another pass at it. I'm just trying to collect feedback right now, so do not hesitate to disagree with what has been done, because it is in dire need of disagreement. There's a lot of things that I'm not happy with, and I'm always happy to get good suggestions. Yeah, I think that's all for me.
Anyone want to ask some other particular question about this topic? I have a
There
question.
were some. It's not okay. Go ahead, Ignacio. Mine is kind of parallel to it, but go ahead.
Yeah, mine is kind of parallel too. So I was just going to ask that Guillaume in the last SQL or the previous one mentioned that I think that somebody was working on 4762 in the spec, like in the Python implementation. I don't know if that's still happening or was an idea.
So on the execution specs, I was gonna take that. I've not made much progress there. I've just about getting started essentially with 4762.
Cool, thank you. Gabriel?
Yeah, I was just going to ask. So it seems like I'm not exactly sure where we are on vertical versus binary, but I'm wondering if we have a plan for like binary tree adjusted 4762. Would that be another EIP, or are we like not there yet?
I'll try to answer that. Yeah. So what the plan is, I would say at this point it's pretty clear that we're gonna go with binary, and therefore Vercel. We're only using Vercel because it's easier to. I mean, this is the code base we have. I am still working on the implementation of binary trees, so I expect, honestly, I think at this point we should the next testnet should be binary, but until we get there, which might take another couple months with all the interrupts and stuff like this. Vercel works, so might as well use it to solve other issues. Now, when it comes to 4762, the structure of the binary tree has been chosen so that it doesn't change anything in terms of gas cost. I'm sure there will be pushback for this, and we will have to either edit it or rewrite it, or maybe just change it completely. But currently, I don't think that's a good use of our time, because the thing has been thoroughly tested. There's of course there's still plenty of open questions. Every time we add a new client, we come up with more questions, but at least it's well understood. and it's still compatible. So I am, as far as I'm concerned, if there's a good reason to change it in the future, that's fine. But I would say we already have a lot of things to change and to adapt to. There's no point in making this more complex by changing this specific EIP.
Yep, perfect. Thanks. That's helpful.
Cool. So we have around 10 minutes left. I don't know if somebody else wants to mention something. Yes, Anish?
I think Guillaume, you mentioned that now next test we should have is with the binary tree. I think we initially discussed that we'll have one worker testnet and also we'll test something for transition. So I was thinking maybe what we can do is we can do what Karim did, and we can, for the transition testing, we can just try to do the transition for Hoodie, and maybe we can do a shadow fork on Hoodie with Workle for testing, or do you think that we could just test this directly on the binary tree?
I'm not sure I understand. You mean like you would want to do the shadow fork in binary already?
No, that's what I'm asking, like what the plan is. So because from what I remember, we had this idea that we'll do a transition testnet as well with Workle.
Right.
I was thinking of like if we don't do that, we can maybe do a shadow fork on Hoodie with Workle and not binary.
Yeah, I think we should do this. I mean, depends how quickly we can all get to the shadow fork. But I would say for now, the main we do have, like, I mean, this is what I said before. Verkle might not be what we like. It's not worth developing Verkle stuff anymore, but it's there. It works, and we all agree on it. So we already had the interop of sorts. We all agree on that. So I would say if we're going to test something like the transition, it makes sense to do the binary tree, the Verkle version of it, and start simpler for the binary tree, which is to do a test net like in a couple months. But I would say, yeah, let's do a Verkle shadow fork, and then focus on making sure everybody agrees on the binary tree format, and only then try a binary tree shadow fork. But that will be, I guess, more like September.
Yeah, that makes sense.
Anybody else wants to discuss some further topic?
I have two things, actually. One of them was a question by Gabriel. You were talking about two forks. I'd like to understand a bit better why you need two forks for the transition.
Okay, so we don't need necessarily two forks for the transition, but something we've run into is that we've used the hard fork Verkle as kind of a the go-to fork for anything Verkle. So previously it's been a Verkle Genesis where execution witnesses are provided and we can do all the like stateless stuff, and this is mostly what we've specialized on so far. So with the conversion, we turn on the hard fork Verkle, but my understanding is that this is when the conversion starts. So if that's the case, then we have sort of a branching logic here where when we fork to Verkle, we are expecting execution witnesses in block and all the other like Verkle related validation. Whereas if Verkle means conversion starts, then this is a different handling. So my question was mainly, am I understanding this correctly, what I've just laid out? And the other part of the question is that how do other clients handle this, and are there like naming conventions for these different sections of the conversion, namely the beginning and the end?
In the case of Geth, at least, it's true we always have the pre-images when we test, so we never did that week-long thing. At least we haven't done it yet. But I would say for Geth it doesn't matter, because we just need to do two checks. The first one is I mean, everything execution related and adding the gas cost and everything, this is active from the moment the transition starts. From the moment the fork happens, because as soon as the fork happens, you create the new tree, and you start writing to that new tree. So all the gas cost, everything is already active at the fork time. Now, the only thing that indeed changes is when the sweep starts and the witnesses are available. For the witness being available, that's also easy. You just have to check that this is Verkle and that the transition has completed. So that for us, we have some flag in our database that says the transition hasn't started yet, the transition is running, or the transition has completed. So for us, that part is very easy. For the transition to start, this is something that does not exist yet. Sorry, for the sweep to start, this is something that does not exist yet, but we would need to have something a bit similar. Figure out when the block was finalized, and when this to do this, we need some support by the CL, which we never had so far. I mean, okay, so that's not true to say never, but let's say CLs are not really concerned by this yet, so we don't really we never got them to implement that thing, and then after this value, the transition starts a week after this value has been written in the database. So once this has been done, once the CL tells us your block has been finalized, we just it's just a matter of adding 2 timestamps and see if we can start the transition.
Okay, yeah, that makes sense. So that clarifies things. This is kind of what I had in mind. So when the Verkle fork starts, we are fully switching over to Verkle, with the exception that the actual sweep hasn't been perhaps started or completed. And one exception is that we are not checking for execution witnesses presence in blocks. Then the sweep is something that happens peripherally, like to be determined what the best way to do that is, and then we need to monitor whether or not the conversion is complete, and then conditionally require execution witnesses to be there in blocks. So yeah, that makes sense to me. I think, I'm not sure where that should go, but to me these things are kind of things I've encountered while testing and coding, and I hadn't seen mentions of it in EIPs. So if we can do some clarifications on that as a side section, I think that would be helpful.
You mean in the EIP itself?
Yeah, maybe the conversion EIP or whatever.
Yeah. No, it belongs. Okay, cool. Sure, we can do that. If that matter is settled, I have another question that I could totally have asked on Discord. It's the conversion test. They have a stride of 0, and do you guys remember why we don't have a non-zero stride?
The conversion tests were really. The conversion test in the official latest release has a stride of 0 because there's no conversion test there. The conversion tests are in a separate branch where the stride is not 0.
Okay, then
I think the
missed that.
stride is 7 in those other ones.
Yes.
Oh, that's a good idea. Okay, then I completely missed that release. Yeah, I'll ask for it. Okay, thank you.
Okay, so I think we can wrap it here. Thanks everyone, and see you next time.
Thanks everyone. Bye.
Thanks. Bye.